All right, welcome everybody. This is 6.3, two-way tables. So two-way tables is another way to compare data when calculating probability. A two-way table organizes data in two categorical variables. So for example, this one we have gender and we have classes, okay? This is information from some of my classes, and then from there we can come up with some probabilities. So one thing you should notice is that we have totals. So this is the total males, this is the total females. Over here is the total in my class and these individual classes. And then here is the grand total. So this is the total all together. This is all of the people in all of my classes. Okay, these should add up to give you the total. This should also add up to give you that total. Okay. All right, so using that, let's come up with some probabilities. So what's the probability, if I randomly select a student, what's the probability that they're male? So basically, what's the total desirable outcome? What do we want? Well, we want to win, we'd have to pick a male. So there's 71 males that we could pick from, and from the total there's 156, so that would be our total. Okay, probability of picking a female, that would be 85 out of 156. What's the probability of me picking a student that's in A1? Well, so that would be, there's 27 of my total students that would apply. What's the probability of picking a student that's in B6? Well, there's 37 in my B6 class, and then that's a total of 156. So for all of our problems, that grand total, our sample space, our universal set will always be our denominator, our universal set. Okay, that's where we're choosing from. All right, now we're using like unions and intersections, so let's kind of think of that about this a little bit more. So what's the probability of picking a male and in B6? So this is, again, intersection, so where the males and the B6 intersect. So here's like our males, here's our B6. Where they intersect would be 16. Okay, so we have 16, wait, what did I say? 14, so 14 out of the 156. Okay, so try this next one, F, the intersection of B8 and females. So B8 and females would be 17 over 156. Okay. So those are intersections. Now let's talk about unions. These are the ones I think are a little tricky sometimes. Okay, so union, again, is we take all of them. So this is kind of like, this is the word like and this is like the word or. So you win if I pick a student from A1, and I also win if I get someone that's in B5. So we want all of A1 and all of B5, okay? So here we would need to like add those together. So 27 plus 28, so that gives you 55. 55 ways to win out of the 156. And then here, let's look at this one. This is interesting. What's the probability of me picking someone in B7 or is male? Okay, so here we got to kind of look at this very carefully. This is kind of like where we talked about we don't want to double count. Okay, so we have a 12, we have 13, 14, 15, 17. And we also, for the B7, we have 15 and 15. But we don't double count the 15. Okay, so ways you could do that is we could just add like we did here, we'd add all of these, just make sure we don't double count. Another way you could do that might be a little quicker is we would add the totals, but then we'd need to subtract one of the 15th because we're double counting. Does that make sense? Okay, another way we could do it is we could take the total and then we would just add the females in B7. So I think that's kind of a good way to do that too. So 71 plus 15 gives us 86. Yeah. 86 out of 156. Again, we could have done like lots of different ways to do that. Okay. We would end up getting the same thing. If we do 75 plus 30, that's 101, but then we'd need to subtract what was double counted. And then you'd still end up getting the 86. All right, so there you go. Here we wrote down our answers as fractions. Okay, our next one asks us to do it in fractions and percentages. So the school district surveys 100 elementary and high school students about eating habits. The following table is missing data. Okay, so we need to fill that in. Use what you know to fill in the missing spots and answer the following questions. Okay, so looking at this, again, we know that these are totals, so we know that those two have to give us 40. So we could do 40 minus 28, and we get 12. Okay, but it looks like there's nothing else that we can come up with. If that's the case and you feel like you're stuck, the reason why is because some of the information is hidden in the word problem. So the grand total of the people that are polled would be 100, and so that's what's missing. So then from there we could figure out the rest. This would have to be 50 because 50 plus 50 is 100. This would have to be 60 because 60 plus 40 is 100. And then we could do something, we could do 60 minus 38. We get 22. We could have also done 50 minus 28. That would still give you 22. Okay, so we filled it in. Now let's answer the probabilities. I'd love it if you would pause and give this a try. So what's the probability that the student ate breakfast? So the total of people that ate breakfast is 60. So 60 out of 100. And they also want us to write it as a percentage. So this one's really nice because if you do that, you do it as a decimal, you'd end up getting like 0.6, and then we'd move the decimal over, and we'd end up getting 60%. Okay? So that because it's out of 100, like your numerator will give us our percentage, but that's not always the case. All right, what's the probability that I'd pick an elementary student? Well, the total number of elementary students is 50, so we'd win if we choose one of those, and it's out of 100. So that's also 50%. What's the probability of like the intersection of high school and breakfast? So high school and breakfast, they intersect with 22. So we'd have 22 out of 100, or 22%. And then the union, so we're taking all the elementaries and all the non-breakfasts together. So we would take all of the elementary, so that's 50, and all of the no breakfast, which is 40, but we don't want to double count the 12. So we either need to do, so if we add those together, if we add 50 plus 40 is 90, but we need to subtract 12. So that would give you 78 out of 100. Okay. Another way, like I said, we could do that is you could do 50 and then just add the 28, and that gives you the 78. Okay. All right. And then we'd write down the percentage. So that's 78%. Okay. Here's just one we were going to do in class, doing some examples. I'll probably just not include that with the video, but it's basically the same. we came up and chose what flavor, what toppings and what ice cream you'd choose, and then from there we could do probability. And you're welcome to kind of come up with your own if you wanted to and do that. But again, it's about the same. So if you have any questions on that, please let me know. We'll see you guys.